Okay, in today's session we're going to discuss we're going to discuss formula manipulation and ratios. Alright, and we're going to start with formula manipulation. Now, formula manipulation in essence is just us following the same old rules that we've applied to solving equations. Okay, excuse me, same rules, following the same rules, and just treating a bunch of different variables in certain cases as if they were constant terms trying to be moved. Okay. Alright, so let's start out with a basic formula. Here we have the distance formula. Distance equals rate times time. D equals RT. Alright, now currently, because the D is isolated, that's letting us know that this equation, D equals RT, is currently solved for the D, because the D is isolated. Alright, but the thing is, what if instead of solving this equation for D, we wanted to, let's say, solve it for T? Alright, well, now that would be no different than looking at this equation as if it read something like this. Okay, the way we would treat this equation is no different than we would treat this one. Alright, T is the variable we're concerned with, so this R and this D would be treated no different than if they were just numbers. Okay, so don't let the fact that they're variables throw you off. So again, we follow our steps for solving equations, and if we were doing the 3 equals 2t problem to get t by itself, alright, I've simplified. There's nothing to simplify, here. Separate, I split the problem at the equal sign, and I see that my variable I want is over here on the right side, so that means I have to isolate it, get it by itself on the right side. So anything that's on the right side with the t, with the variable that I want, has to be moved over to the other side. And in this case, the 2, alright, the 2 is the only thing that's over here with the t on the right side of the equation. So I have to ask myself, in order to move it, and remember, inverse is the step where we move. In order to move it, I ask myself, is the 2 attached or detached from the t? In this case, it is attached because it is not separated by a plus or minus sign, so this would be considered attached. The 2 is attached to the t, and because they are side by side, that lets me know that I'm looking at multiplication. Side by side indicates multiplication, the operation of multiplication. So to undo it, the inverse of multiplication would be division. So now I'm going to divide, so I'll make my fraction line to indicate I'm about to divide. I'm going to divide both sides by the number that I'm trying to get rid of, which in this case is 2. So I divide both sides by 2. Excuse me. So now here the 2's cancel. My t is now over here by itself, and on the left hand side I have a 3 over a 2, and since 2 doesn't go into 3 evenly, I can simply leave it as a fraction, 3 over 2. Alright, so 3 halves is equal to t, or t equals 3 halves. Easy enough. But now it's applying the same concept to this formula over here and treating the D and the R as if it was the 3 and the 2. So again, I want t by itself, so I have to get rid of the R, because the R is on the same side. If I separate the problem, the R is on the same side as the t. The R is attached to the t. They're side by side, so that indicates multiplication. So to undo multiplication, the inverse of multiplication is division. So I make my fraction bar, which indicates division, and I'm trying to get rid of r, so I divide both sides by r. And by dividing both sides by r, they cancel on the right hand side. T is now by itself, and on the left side I simply have d, excuse me, I'm about to write t, it needs to be over r. And there you have it. So now I took the equation that initially, or the formula that initially was d equals rt, and manipulated it, okay, arranged it so that I got what I want. That's what I mean by manipulated. Alright, I manipulated the equation so that I got t solved, or t by itself instead of the d. Okay, so that's all we're really talking about when we're saying manipulating formulas. Alright, let's look at some additional examples. Let's say we have, there's the formula for simple interest. Simple interest. There's a lowercase I. Interest, lowercase I, equals principal times rate times time. So currently this formula is solved for I because the I is by itself, it's isolated. Alright, but let's say we wanted to take this formula and instead solve it for R. Okay, so now we want to get R by itself. Well, we go through our steps of solving equations. Go through our steps. And we look to simplify. There's nothing to simplify. So we separate the problem by splitting it at the equal sign. I notice that my variable is on the right hand side, so I want it isolated on the right side by itself. So to get it by itself, I have to move this P and this T over to the other side. Now notice the P and the T are all side by side with the R, so that indicates multiplication. They're attached to the R. They are not separated by a plus or minus sign, so that tells me they are attached to the R and in the form of multiplication. So to undo it, I do the inverse of multiplication, which is division, and I divide both sides by what I'm trying to get rid of, which in this case is a P and a T. So now P's cancel, T's cancel, and if I divide by a P and a T on the right side, I have to divide by a P and a T on the left side. So I over PT, I over PT equals R. There it is. My R is by itself. So I took I equals PRT, manipulated it, and solved it for R. Okay. Another example. Let's look at, let's see. Let's say the area of a triangle equals 1/2 base times height. Area of a triangle equals 1/2 base times height, and I want the height. So currently it's solved for area. Area is what's by itself right now. Okay, so this formula is currently solved for area, but I want to take it and rearrange it so that I solve for height. Okay, so again, I follow my steps. Simplify, nothing to simplify. Separate, split the problem at the equal sign. My variable's on the right hand side. Okay, so I want to get H by itself, so I have to get rid of the 1/2 and the B. Now in the case of this 1/2, I can cancel it by multiplying both sides by the reciprocal of 1/2. So the flip, if you took 1/2 and flipped it, it would become 2/1, and 2/1 is just 2. Okay, that's what we consider the reciprocal. Flipping a fraction, the flip of a number would be considered its reciprocal. So if I flip the 1/2, it becomes 2/1. All right, which basically is just 2. So I multiply both sides by 2, and multiplying it on the right side allows my 2 to cancel my fraction out, and on the left side 2 times a just becomes 2a. Alright, so I have 2a equals BH. Still trying to get H by itself. Split the problem. To get rid of the B is attached to the H in the form of multiplication, so to undo it, I divide. So divide by B on the right side. I have to do the same thing on the left side, so I divide by B on the left. B's canceled on the right. On the left, I have 2A over B equals H. H is now by itself. It's in a positive form, so we have isolated H and thus solve this equation for height. Alright, let's look at another one. Okay, we have y minus y1 equals m times x minus x1. Okay, and I want to solve this one for x. Alright, currently this one is solved for y minus y1. Okay, if you want to say that. Alright, and this is considered the point slope equation. Okay, we want to get x by itself. Alright, nothing to simplify, so let's separate, split the problem. Now here's the deal. The issue is the variable I want is inside of parentheses. Now normally I say you move what's detached from the variable before moving what's attached. If you notice over here, I tell you to move what's detached from the variable before moving what's attached. Alright, but if the variable that I want isolated is inside of parentheses, then I need to deal with everything outside of the parentheses first before I deal with anything inside. So I need to deal with everything outside of the parentheses before I deal with anything inside of the parentheses. Okay, so I tell myself, looking outside of the parentheses, I have this m. This m is next to parentheses, so that's the indicating multiplication. Alright, no different than if you saw something like this. Again, something next to parentheses indicates multiplication. Alright, so to undo the multiplication, I'm going to divide. So I'm going to divide both sides by what I'm trying to get rid of, which in this case is an m. So I divide the right side by m. If I do it on the right, I must do it on the left. So now I have y minus y1 over m equals x minus x1. Now notice I took the parentheses off. The parentheses aren't here anymore because I removed all of the terms, all of the items that were outside of the parentheses. The m was outside of the parentheses. Now that it's gone, I don't need the parentheses anymore. Okay, so again, I'm still trying to get the x by itself. Still trying to get x by itself. I separate. I want the x by itself. So now I have to get rid of this minus x1. And since this x1 is now detached, it's detached from the variable I want, I have to use additional subtraction to move it. In this case, since it's minus x1, the inverse of minus x1 would be plus x1. Alright, so if I add it to one side, I have to add it to the other. So over here they're going to cancel. Now, I have y minus y1 over m plus x1. Because these are not like terms, I just write it out. So I write out y minus y1 all over m plus x1, and that would equal my x. Alright, one last problem. Okay, let's go with a perimeter problem. Perimeter, let's say for a rectangle, equals 2 times the length plus 2 times the width. Alright, currently this formula is solved for P, perimeter, and we want to, let's say, solve it for length. Okay, we want to solve for length. Alright, so separate. There's nothing to simplify, so we go to separate. I want to get L by itself. Now if I want to get L by itself, I know I have to move this 2, and I also have to move this 2W. Okay, so I ask myself, which one do I move first? And again, based on moving, we know inverse is the step for moving, and under inverse we see that we move what's detached from the variable first, and this 2W is detached from the L because it's separated by this plus sign. So if I want to move a plus 2W, the inverse or opposite operation of plus would be minus. I'm trying to get rid of a 2W, so I subtract 2W on both sides. Okay, 2W's cancel over here on the left side. Because these are not like terms, I just write it out. P minus 2W equals the 2L that was left on the right hand side. Okay, I want to get the L by itself, right? So I got to get rid of this 2. So the 2 is attached to the L, it's connected, attached in the form of multiplication. So to undo it, I divide. And I want to get rid of 2, so I divide both sides by the 2. 2's cancel. So now I have P minus 2W over 2 equals L. Alright, so that pretty much does it for formula manipulation. So now we're going to switch gears and talk about ratios. Okay, I want to talk about ratios. Alright, and basically with ratios, what we're looking to do is to get some amount over a base and set it equal to some partial percentage. Alright, some partial percentage over a total of 100%. Okay, alright, now another way I like to write this is over of equals some partial percent over 100%. Okay, so let's look at some examples. Typical problem would be stated as such. Let's say 12% of what number? 12% of what number is 47? 12% of what number is 47? Alright, that's the question. 12% of what number is 47? Okay, so this is how a typical problem would be formatted, let's say on a test or a quiz. Okay, so when we look at it, we look at the first number we're given, 12. Well, what is 12? 12 is what we would consider our partial percent. So now we have is over of equals 12 over 100. Okay, now it says of what number? Of what number? Alright, because it's saying what number, that's indicating that of some number that we do not know. And when we're talking about an unknown in algebra, we represent that with a variable, typically x. So of what number? Of x. So since we say of is on the bottom, we would say the unknown is on the bottom. Alright, and then it says is 47. Is 47. Okay, so our 47 is associated with is. So where the is goes, you write 47. So now you used all the information given in the problem, and the ratio you end up with looks as such: 47 over x equals 12 over 100. Okay, so once you have your ratio set up, then all you're going to do is cross multiply. So 12x equals 4700. Okay, so now we go back to solving equations, right? We go back to our solving equations. Nothing to simplify. Separate. The variable we want is x. Alright, so that we have to move the 12. The 12 is attached to the x in the form of multiplication, so the inverse of multiplication would be division. So I write my fraction bar to indicate division, and the number I want to move is 12, so I divide both sides by 12. 12's cancel, and therefore x equals 4700 divided by 12, which would be 391 point, let's say 67, and that would be your answer. So basically you're saying 47 out of 391.67 represents 12% out of 100%. Okay, that's what we're doing. Let's look at another example. Okay, let's see here. Let's look at what number is 90% of 45. What number is 90% of 45? Okay, what number is? Alright, what number? Remember, when it says what number, that's saying we don't know, and the unknown is represented by a variable. So the variable is, so we say, remember, it's is over of equals some percent over 100%. So our is x equals, they give us 90%, so that's our partial percentage, and we know that is out of 100%, and of 45, of goes on the bottom, so we write our 45 on the bottom. Cross multiply, so now you have 100x equals, what is this, 90 times 45, so 4050, divide that by 100, and you have x equals 40.5. Okay, let's look at another one. 87 is 60% of what number? Excuse me. Erase. Of what number? Okay. So 87 is 60% of what number? Okay. 87 is, our is on top, so 87 is. 60% is our partial percent, so it goes over the 100. Of what number? What number? Again, of what number? Of x. There you go. Cross multiply. So you have 60x equals 8700. Divide by 60, and you get x equals 145. Alright, one more. Let's do 11 is what percent of 200? 11 is what percent of 200? Okay, 11 is is on top, so 11's on top. What percent? What percent? What indicating we don't know an unknown percent. So remember, our percent goes in the top over 100, and of 200, of 200, of goes on bottom. There's your setup. Cross multiply. So you have 200x equals 1100. Okay, 1100 divided by 200. X equals 5.5. Okay, double check, make sure I have everything written out right for you. Okay, that, okay, alright, so that pretty much sums up ratios. So we've talked about, again, formula manipulation, which is just following the steps for solving equations. Alright, and then we just discussed ratios, which is all about just taking the information that you're given and putting it in this form right here. Is over of equals some partial percent over 100%. Once you get it in the form, it's just a matter of cross multiplying. It's a matter of cross multiplication and solving for your unknown. Hopefully this helps you with dealing with these two subjects, and as always, feel free to contact me if you have any additional questions about either topic. If there aren't any questions, this will conclude our session.